Hello student, welcome to our physics discussion, that is physics in a smart way. We continue where we are left from the last class. So as you know, we got two objects. We usually discuss under two objects. One is the SHM making body, that is body number one. Body number one which executes uniform circular motion. That doesn't make SHM, but that is a creator of SHM. And if you draw a perpendicular or a normal onto x-axis, the foot of the normal, the motion of the foot of the normal on x-axis, we got real interest on it, and that does SHM, that is body number two. We mark it as a body, and that is body number two. That moves to and fro. Okay. So the position, just like in the last class of the body, SHM making body of the body number two is given by position vector or coordinate equal to A cos omega t. And because everybody knows, at least all of us have got the common sense to know that this is not this foot of the perpendicular is not a body at rest that moves to and fro. So if that moves to and fro, that must be having a velocity. So if you are interested to find out the instantaneous velocity when the body is at this position, that is moving towards left, automatically it is known, it is seen, and that is moving with how much velocity or what is the speed, velocity. If you want to find out, then velocity can be found out by mathematical ways. We know velocity vector will be a rate of change of its position or derivative of its position vector with respect to the time. That also means the same as dx by dt, rate of change of its position with respect to the time. And if you make it, then we know that x coordinate or position vector was a cos omega t, derivative of that d of a cos omega t by dt. And as I had given you the formulas, then we got derivative of this cos derivative will be giving us minus. So minus a omega sine omega t. If that is equation number one for today, then that must be equation number two. That is the equation of velocity. Some of us may be a bit surprised by the result. The result has got a minus sign. The minus sign shows that the velocity is in the opposite direction. Opposite to what? Opposite to position vector or x coordinate. You know, body is to the right of the origin, and you know velocity is towards left. If somebody writes velocity in the strictest possible sense, the velocity must be written as a omega sine omega t I cap. Sorry, let me modify it. A omega sine omega t into minus I cap. Okay, we clearly see the velocity has got a minus sign, that is in the negative x direction. So due to that, the minus sign appears, nothing else is to be seen, or it is not so sinister, so that we will be worried on it. So thereby, as you know, because velocity is opposite in the negative x direction, and some of us may be a bit worried. The way we did find the velocity, that was a bit mathematical. The velocity is the rate of change of displacement or derivative of displacement or derivative of position vector or derivative of x coordinate with respect to time. That seems a bit mathematical. If somebody wants physical explanation to that, we can also provide for that. But for that, I have to pause the video for a bit, then we can. Okay, I needed some space. So, and there is some modification to the diagram. We know the body number one, or the main body, moves around the circle with a constant speed, and the speed is branded as u. And because from the circular motion, from the uniform circular motion, we know velocity equal to omega into r. Omega is angular velocity here, into r, radius of the circle is a. In the SHM context, they have got different meanings, of course, but we are discussing the motion of the main body. Okay, so main body moves because the foot of the perpendicular, or foot of the normal, we are studying the motion, and that does SHM. The foot of the normal moves because the normal moves, and normal moves because the main body moves. Okay, and if you look at this normal, because the main body moves, the normal also moves. Normal doesn't become tilted. That doesn't tilt like this or like this, like that. That moves. So thereby, automatically, our common sense says the along x velocity along x of every point on this normal will be same. So if the foot of the perpendicular normal is a velocity v, that must be derived from the main body velocity, that is ux. Ux, v must be equal to, we can write, v must be equal to ux. And if you go for finding the us, this angle is theta, this angle is same as theta, this is 90 minus theta, and this angle is again theta, this is u, this is uy, that is ex, and ux equal to your u sine theta, and u equal to omega a into sine theta, and you know theta means omega t. So that is u omega I into sine omega t. So thereby we know we are getting the same thing here. But some of you may be wondering, there I was getting negative sign, here it is not. Here we do not need the negative sign, it is already directed towards left. If we say a velocity like this, and this velocity is minus 5 meter per second, then the meaning is different. That original means that is towards left, and having a magnitude which is starting with a minus sign, that means the velocity is towards right. So thereby the correction is given only for once, not twice. So because the velocity, the direction, real direction is clearly shown to you, so here the formula, this thing gives you the only magnitude, and magnitude remaining same, that is a omega sine omega t, but differentiation was giving the direction also. So that is the physical confirmation. How come the velocity is having this value? And now you got that. Now you got that. Once you got that, we also see, let me remove it because we need some space. We also see that the velocity also is not constant, because that contains a torque, that is t, and as t changes, omega t or sine omega t will be assuming different values. So velocity is not constant. Acceleration is bound to happen. Acceleration is there once the velocity changes. So if I go for acceleration, then acceleration A, we know that is rate of change of velocity, that is rate of change of velocity with time, or derivative of velocity with respect to time. So if I do find that, then derivative of the velocity was minus a omega sine omega t dt, that will be equal to, again, the sine omega t. the derivative will be following the sin nx rule. So thereby we'll be having minus a, another omega will be coming out. Omega mixed with omega square, sin omega t becomes cos omega t. So acceleration is minus a omega square into cos omega t. That is equation number 3. Equation number 3. One thing you can see that, let me clear up some space here, or else it will be, these things are covered up. Acceleration as it comes out, sorry, I have removed r, you can recall it at any time. Acceleration as it comes out, that comes out as minus a omega square into cos omega t. That is equation number 3. But already you know the position vector or the coordinate, x coordinate equal to a cos omega t. So we can clearly see the position vector of x coordinate is coordinate or position is directly there in acceleration. And if you substitute that, then we know that acceleration will be, that is, minus omega square into x. A equal to minus omega square x. There is much to read in this, and that we'll be discussing in the next video. But we must have a practice of it, and we must bring it. Right? You must be sure of the equation. Let us say that is equation number 4. That is equation number 4. But one thing I have missed midway, that is, there is another formula for velocity. But if you allow me to remove it, we do know that velocity equal to just a minute. Velocity equal to minus a omega into sin omega t. Sin omega t we can written as sin theta. Sin theta, if we consider this right angle triangle that we get here, this right angle triangle we do know has got, this right angle triangle has got the base is x, hypotenuse is radius, that is amplitude a, this angle is theta. So the perpendicular, automatically using Pythagoras theorem, we know that must be equal to root over of a square minus x square. You can easily predict it. So thereby we can write it as minus a omega sin theta. Sin theta, in this case sin theta, you can say that is a square minus omega square by a. So thereby we'll be having, that is minus omega into root over of, minus a square, not omega square. I'm sorry. A square minus x square in terms of position, not in terms of angle. A square minus x square. So that is one of the formula velocity, and this you can take that as equation 2 dash. So that's all for today. Shall be continuing in the next class. But remember, we have left with an equation that acceleration equal to minus omega square x. this equation is very much meaningful. A hell lot of property of SHM, simple harmonic motion, will be coming out from this, and will be this will be helping us in exploring SHM further and further. But that will be to the next class. So thank you for today. Please give me a like if you like it, subscribe and share.